So let's look on page 68. And it says use a calculator to find the decimal approximation for each value. Give as many digits as your calculator displays. Simplify the expression before using the calculator. All right, number 6. It says cotangent of 41 degrees, 24 minutes. Now, if you look at your calculator, notice they have sine, cosine, and tangent. They don't have cotangent, correct? So what you have to do is you have to get cotangent in terms of tangent. So what is true? The cotangent of an angle is equal to what? 1 over the tangent of the angle, right? So then what I do is I say this is equal to 1 over the tangent of 41 degrees, 24 minutes. And that is going to be my answer. So I go in here and I put 1 divided by tangent of 41. Now I'm going to have to force the degree because I got minutes. So I go in second angle, enter on the degree, and then I have 24, and I go second angle, and I can get minutes. I can just push 2 and it'll give me minutes. Push enter, and then they said as many as your calculator shows. So it's 1.134277349. Now, as a side note, let's just say that you had sine of 21 degrees, 20 minutes, and 15 seconds. Well, you'd put that, the way you'd put that in your calculator, you'd have to go sine 21. You're going to have to force it. Even though the calculator's put in degree mode, I'm going to have to force the sine. So I got to go second angle, and I can just push 1. And then I got to go 20 second angle, and then I can just push 2. But now notice that there's no minutes. Seconds, excuse me. There's minutes. 2 is minutes, but there's no seconds. So then I have to do 15. And if you notice down here, there's 2 little things. You have to go green, go down there. Now you got the seconds. So you go to second angle for degrees and minutes, but then you go to that second green and push that thing to get those quote marks. And that'll give it to you. Then you push enter, and it'll give whatever the value is. So this section does not do seconds, but if you do seconds, that's where it's at. It always takes me a little while to figure out where the heck it's at. I know it's on the board. You just have to kind of look and see where it's at.
Got a question on that. When
Yeah.
I did that, my calculator kind of rounded off where after that 6. Okay.
Well, if you go into mode, where am I at? If you go into mode, you see where it says Oh, where's it? Here. See, I got my decimal point set at float. Do you have it set at 1, 2, 3, 4, like how many digits?
Says close.
Okay, so you've got it set at 6 decimal places.
So is there a way to shut that off?
Just go into your pusher mode and get this screen up, then go back here and highlight. You'll have to down arrow and then get it on float and then enter on float. See what yours has done is it's over here and it's doing 6 decimal places. So you can force it to do however many decimals you want. So just make sure, you know, if it looks like it's something not right, go into mode and look. So you just put her back on float if you want to have as many as, and it'll just float it then. Notice, so you can have your calculator set normal on scientific notation or engineering notation. So if you want to have it that way, you can put it in however many decimals you want. So if you put it at 0, then it'll just show you the integer. And then this is functional notation. Here's parametric, polar notation, and sequential notation. So if you want to graph polar coordinates, you can do that with this thing, or parametric. And then this thing, when you're graphing, this connects the dots, and this just runs the dots out. And sometimes it's advantageous to just see the dots, the points that are plotted, not. Especially when you have something like a vertical or a horizontal asymptote where there's really no solution, there's no points there. And what it'll do is it'll make it look like there's a line going through there when there's no line. Maybe I can show you what I mean. If I put in an equation 1 divided by, and put a bracket, x minus 2. Now, what can you not divide by? Don't look at this, just tell me, what can you not divide by? 0. So this equation is undefined at x equal to positive 2. Because at positive 2, you're trying to divide by 0. There's no solution. Now, so technically when I graph it, it should not show a point right there. But here's the connect. What I'm telling the graphing calculator is, as you plot points in your pixels, you connect them. You connect the points. Well, there's nothing at 2, but when I graph it, it's actually doing dot. This is what it should do. If you have a calculator, just try putting, see, and this is showing me what it should be. What I'm trying to show you is this calculator is smarter than the average. So let's see whether I can make it. It'll just, I know what I got to do. I got to go mode. I got to put it in dot. And then see the line isn't solid, but the calculator knows not to put a line connecting those two. Wonderful. This calculator is. Try it on your calculator, and if there's a vertical line right there, then try switching it over to dot. Yeah, this one. This one connects the things, but it knows not to connect. Try your calculator and see if it's in connect mode, and put that 1/1 x minus 2 and see whether there's a line that goes from here right straight up there. Some calculators will, and it'll be because it's in connect. Does anybody have it? That a line goes up that graph? Oh, well, the graph is right there. You put your equation in here, y equals. You put your equation, see, I got it at y equals this thing right here. And then I put 1 divided by the quantity x minus 2. That makes the vertical asymptote at plus 2. And then once you got that, then just go over here and see it where it says graph, then just graph it. Does anybody's run it with a line straight up and down right here? Anyone? Huh? Yeah, yours is just like mine. See, now go into mode on yours and see what is it set at. When you go in, it's in connect.
Yeah.
So it's smart. See, if you have an older calculator and it's set in connect, some of them will run a vertical line right there. But see the difference on this calculator between connect and dot is that it plots the dots. Now when I graph it, you see it's just a set of dots. Now if you have a calculator that runs a line when it's in connect that goes from, looks like it's continuous, then put it in dot and look at it. Apparently nobody's got a calculator that tries to connect those and makes it look straight through. What?
I don't even have the same option.
You must have something different than a. You don't in the mode
I have different options than you.
here. What it must be an 84 what? Plus silver.
For the color.
Well, you got thick dot, thick thin.
Not under the connect sequential and simulations what I get.
Yeah.
I don't have connected or dot at all.
Yeah.
I just have the thickness of my lines.
I don't know. If you happen to have one that.
That's right. So.
Yeah. You just got to know what your calculator's showing to you. And some will graph it wrong, depending what you have set up. All right, let's see. Let's go back and look at some more of these. Now 10 is pretty straightforward, I think. It just says the cosine of 421 degrees, 30 minutes. And you just put that in just the way it is. Because we have cosine and we can put 421. But we're going to have to force a degree. And then put 30. Yep, I did something wrong. All right. Now, if you look at cotangent of, look at 14. It says cotangent of negative 512 degrees, 20 minutes. So what did we say we have to do? 1 over tangent, right? Negative 5, 12 degrees, 20 minutes. Now, when I do that on my calculator, you should work some of these and see how years work. But when I put that minus, don't put this minus. It'll, if I put that minus, it will give me an error message because the first minus in the problem has to be that minus. Now it's, if you put the wrong minus sign in, it will give you an error message. And then usually you want to go take me to the error. Okay, 1, 20. Oh, crap. I'll show you what happens if I don't put, if I put the wrong tangent back. Let's say I put this negative in, and I'm just going to put negative 30 because it don't make any difference for the purposes of showing you. And then I push enter. It's going to give me a syntax error. And the best thing to do when you get that syntax error is go to where the problem is. And then it takes you there. And then you say, all right, what I did is I put the wrong sign in. And then enter it. And then it corrects it for you. So if you get a syntax error, go to the go to. If it'll either take you right to the spot that it's at or take you real close, depending on what the syntax is. Now then, the next set of problems says find the value of theta in the interval from 0 to 90 that satisfies each statement. Leave answers in decimal degrees. So this kind of a problem, what you're going to have to do is you're going to have to make sure your calculator is in degree mode when you do it, because otherwise it'll give you back to radian mode. It'll give you radians. Let's see. Let's just do the 30. We know that sine of 30 is 1/2, but let's put it in the wrong mode, because then if I do the sine inverse of 0.5, then I should get 30 degrees, right? If I have it in the wrong mode, and I go sine inverse of 0.5. And it's going to give me a number, and that's a radian. That's how many radians it is. So you better, if you're doing sine inverse, you better be darn sure, and you're expecting to get degrees, you better be darn sure you got your mode right. So once again, what's the trick you do, they said to do, is start your work out doing sine of 90. And you see it's in the wrong mode because it's not giving me 1. So then I go in, change my mode to degrees. And then I go back and do the sine of 90. secants give me 1. So now I'm in degree mode. All right, so 26. No, forgot it. What? Don't ask questions like that, is that what you said? 26. Secant of theta equals 1.1606249. All right, we don't have a secant, so we can't go second inverse secant, right? But secant is equal to what? 1 over cosine. So what you do is you put 1 over cosine is equal to 1.1686249. So then you have to invert this, and that means you invert this. So cosine theta is equal to 1 over 1.1686249. And then theta, this is supposed to be a 0? Not 8, so this is a 0, 0. So then this is cosine inverse of 1 over 1.1606249. So now the angle that we're going to deal with is second cosine 1 divided by 0.1606249. So it's a little over 30 degrees. So that's what you're going to have to do with those in order to use your calculator. Now, on page 70, it's telling you to use use a calculator to decide whether the statement is true or false. It may be that a true statement will lead to results that differ in the last decimal place due to rounding error. So if we go 46, we go 46, cosine 70 degrees equals 2 cosine squared 35 degrees minus 1. Now, whenever it's in here, if it's a minus 1, then it's the inverse. But if this is squared, so this is the same thing as saying so you can do that. So what they're telling you to do is to do the cosine of 70 and then do 2 cosine 35 degrees squared minus 1. Now, they're the same. Now notice that you see it sets it up this way. That's square in the cosine. Okay, let's see what we can. Go down, let's look at 54. Tangent squared 72.25 plus 1 equals secant squared 72.25. So the first one we can do tangent 7.72 second angle 125. That's that one, and then now secant squared, so what I'm going to have to do is, because secant's not in there, I'm going to have to do what? Secant cosine, right? Secant and cosine. So secant squared 72 degrees 25 minutes is 1 over cosine squared 72 degrees 25. So I have to do 1 divided by cosine 72 So they're not the, what? Oh, I didn't square it. Shoot. I can go, I think I can just square that. No, I can't. If I squared it, then it's going to square that. It's not going to square the thing in the denominator. My upper, this one here?
Okay, now you can edit it.
Okay. So now I got to get, I might be able to square it. If in doubt, then you go back and bracket that thing in the denominator. I guess it'll probably work. Okay, and you bracketed this thing from here back and double bracketed back here. So it's not true. Thought I didn't square the first one. I didn't square this thing because that was supposed to be tangent squared. Can I do this one? So I can edit this one too. Huh? Weird. Plus 1. Yeah, now they got the same. You're right. Okay. So that's what they're asking you to do with the calculator. We'll look at the next section. right angles. And then they're gonna talk a little bit about significant digits, which I'm not gonna be real interested in, but for purposes here, when you're doing angles, notice that if it's just a degree, not minutes and seconds, it's 2 significant digits. If it has minutes, it's 3. If it has, I guess to the nearest 10, or then it goes to the nearest minute, it's 4, and then the nearest 10 seconds, it's 5. So we'll have to use that stuff. So I guess that. See you Monday. Yeah. Yeah. Oh, Corey, I checked your name. What'd you say? No, he didn't. I forgot. And I had a meeting and I wasn't able to do it. Thank you.